Nice to meet everyone. My name is Kevin Grover. I'm head of product at a company called Preview 3D. I guess I let a few Canadians across the border here. I don't think there's too many of us here, but we're a small software company that's based out of Montreal, Quebec. I work remotely in Edmonton, but a little bit of background about myself. I'm actually a land surveyor by trade. Was working for a large engineering firm for a long time and decided to jump over the software dark side and joined Nick at Preview about a year and a half ago, and we're trying to build some exciting new tools and present some reality data in a little bit of a different way. So happy to talk to you about what we're up to here today. So of course, looking online and what kind of makes a catchy opening for presentations. So I figured I'd start with a little bit of a slide here. Of course, it's probably some made up specs here, but really what we're looking at here is they're brownfield environments. There's a lot of existing environments that have never actually been digitized. So I think that's a huge opportunity. We've heard from other presentations of other people here the last 2 days. Huge, massive opportunity for how we can leverage the scan data and really make a change in the world. So of course, I've got the slide showing all the different scanner types. I'm not going to go over everything here again, but we've seen there's a lot of different options for how we can collect and capture data. From higher end terrestrial scanners to some of the SLAM devices like the Navis unit upstairs. We got some, drones and photogrammetry, and of course, what Exxon is talking about. Everybody's got a phone in your pocket. We can start kind of using data that way. I think as a surveyor over the years, we've always had challenges with all these different sensors and merging together and all being usable. To be honest, all the data can be valuable. It can all be used in different ways, and that's really what we're trying to look at doing at Preview, is how we can merge all this data together, take this great information, and present it a little bit differently. The problem I think that we've seen, as everybody's here for, and why we're looking to learn, is point cloud data is challenging, and that's really kind of the byproduct of all of these tools. So of course, I'm going to, forgive me by saying point cloud data is dumb. I think we've seen this in a lot of the presentations here today. It's unintelligent. I guess that's what I mean by it's dumb. It's a series of unordered points. They're all disconnected from each other. They might look great on the surface, but nothing actually defines a shape. Nothing defines an object. It actually is just a collection of 3D data that you have to manually interpret. The huge data volumes, which has always been a challenge with working with this information in the past. And also we've relied on very specialty software and specialty people to use. So I think that's been one of the problems that we've always seen over the years. I've been scanning for far too long, I think since previous early scan station days, I guess, with Leica, which is why challenges for mainstream use. If we look at what Exxon's trying to do with all this data and their digital ecosystem, we're looking at how we could fit in and do that the right way, on our way as well. So we're trying to do this a little bit differently. But currently, right now, the process is, as you see here, there's always a purpose of scanning to something, and we forget about a lot of the original data. Maybe we're just using it for measurements, 2D CAD, looking at images, or converting to CAD models like 3D CAD or BIM models, doing animations. They're all converted to something just to make it consumable to more people. But our goal is to make this a lot more consumable to everyone. So really at Preview, we're trying to make reality data more the end deliverable that we can build on top of, leverage, visualize, work with, and just have it as part of a bigger part of our life. So the big thing that we do, there's a couple of companies here, but Cintu and Point Fuse and a few others that are reality meshing. So we're seeing a lot more of a theme of generating a mesh from data. We feel that this is really a big foundation of how we're trying to build our product and our software. So it's all created from the data that we're capturing already, whether it's a handheld scanner, like the VLX backpack unit or a terrestrial grade scanner. It's all as high fidelity data that we can capture, the better that we can actually create a mesh from it. So the screenshot we see here is actually kind of a hybrid of what we're doing. We're focusing on the really, really high precision meshing. Very different than doing aerial capture, satellite capture. We're looking at the finite fidelity for doing engineering design, asset management, how we can actually look at these digital built worlds a little bit differently. So the benefit of meshing is things become connected. So the fact that we actually mesh and create 3D shapes within the data, everything becomes connected as triangles. This allows us to do a lot more with it, that we can photo texture, add that realism, we can tie it into gaming engines, and as there was discussions yesterday as well, making data compression is also a big one as well. We're always confined with storage requirements on projects. Sure, the cloud is great, we can throw more storage at it, but having a data set that can be shared, consumed online, consumed on different devices, making it streamable on a mobile device, that's really where we have to start looking at how we can display the data a little bit differently. So being game engine ready is one. We've heard that before. It's how we can start bridging the gap with Unity and Unreal. See the announcement with Autodesk, I think 2 weeks ago at their Autodesk conference, where they're making Twinmotion available, and they're really kind of partnering with Unreal, opening up a huge opportunity for the design community to start using this data a little bit differently. So a little about Preview 3D. We're a small software startup based in Montreal, but our core technology is really based on these 4 pillars that we're really kind of focused with. We have our own proprietary mesh engine that is one of the fastest meshing engines on the market. We do actually rely on fully cloud automated processing. So I'll show you a little bit more detail of all these as we go, but we make it as easy as drag and drop. So when you capture the data with your scanner after it's registered, we take that, we mesh it the highest precision mesh that we can. It's a level of detail streaming, so we can actually support a massive point cloud data set. And then we actually photo texture with the images that are captured with the scanner. That just allows it to give the ultimate realism with the data set. As we get into these different buckets, the segmentation is something that we see as a bit more of a common theme here. Is we really want to start making the data smarter earlier on. So we've got some new tools that we're just going to be announcing. We're working actually in beta with some early partners on it right now, which allows us to start finding and identify objects and assets within a 3D space. So as soon as we capture this beautiful 3D data in a brownfield space, we can actually start knowing where different things are within that environment. We've always been a very visual platform, which we'll see in some of the data here later on, but the biggest thing that we also do is we make reality data editable. I think this is the one kind of challenge we see with a lot of platforms in the market that we've always had issues with is you've got this static data set that you have to convert to something, but we've got tool sets that allows you to start to cut and slice and edit objects all within this reality mesh data set. It's all easy to use, very visual. You can export to 3D applications as well. And this is really where we're starting to bridge the gap now between this editable data and how we can start connecting up to other information within the space. The last one, of course, is visualization. We always see pretty point cloud fly-throughs and great visuals of what a data set can look like. It's usually a video or a static image. We're fully immersive. We actually make basically a video game out of your reality data. So I've got some slides, but I'll show you live at the end of this here too. So like I said, as far as the mesh processing, this is our interface. We do support different data, and you saw my slide at the beginning there showing all the different sources of data. We, of course, do have our preference of data. It really comes down to just the ones that are right for meshing with the quality that we're after. We can technically mesh any point cloud data, but deliver that level of realism, we've started with more terrestrial data. We do support some of the Matterport data sets with their E57 export as well. SLAM, we've got a really good relationship with Navis and the VLX teams. We actually leverage that. We can mesh it and have these much larger scaled environments. And then meshing as well from photogrammetry. We do actually ingest that, convert it to our level of detail mesh, and open up a bunch of the tool sets that allow you to work with the data. So the big thing as part of our workflow, I think this was even brought up yesterday in one of the presentations too, is we do actually validate data on upload. I'll be clear on that front too, is we're very best practice driven with how to capture data for the purposes of meshing. In the side of this room, you could do a couple of setups and capture it to generate a floor plan, but it's certainly not enough data to actually create a very detailed mesh with lacking occlusion and get every little nook and cranny. So we actually do some analysis on the data when it's uploaded to make sure it meets our requirements for having pictures included, detail in the data, with some of the SLAM systems if it has all the other additional information that's needed as well. But it's as simple as drag and drop once you get it up and running. So I mentioned we're cloud process, so this actually allows us to take these massive data sets, store those data sets and convert them to a reality data set as fast as possible. So one of our biggest data sets to date, just for an idea, is about a 1.4, 1.3 terabyte point cloud data set with imagery, and it was processed and meshed in about 8 hours and delivered on our cloud platform and a desktop application. So we're trying to get to a deliverable that's faster. I think even in the presentation Merrick did yesterday for Navis, the goal with this new technology is to scan and capture data next day. We're looking at doing the same with our end, make it available, more usable to more people. One of the biggest differences also about our engine is we do some very advanced texturing with our data. So with all of the 360 imagery that's captured with these scanners, we actually use that to photo texture. So you can actually texture with just the point cloud coloring from the data, or you can actually texture from the imaging. So some of the pictures you see here is the goal for us is to not get rid of the 360 panoramic image, but actually texture it over top of the mesh and actually allow you to have this immersive environment that looks exactly like looking at a picture. So I've got some great data sets here that we'll show you that as well. The holy grail, of course, now is how we can start making better, faster decisions with your data. So this is actually a new feature that we got in an early beta for some of our early customers here right now, is how we can actually start organizing a space automatically. So as part of our pipeline for doing the cloud processing, we actually can fully segment and isolate objects within the space. So we can easily identify things you see here between walls, floors, ceilings, HVAC units. We're getting into smaller items like pipes and flanges and valves and that kind of thing within the space. The goal of this is now we're going to have this more layer-controlled version of a reality mesh data set that we can start using for more things that fit within some of the tool sets that we've got, and also within some of the design integrations we're looking at doing. For more finite objects, we've also got more of an object, like an image extraction feature set where you can actually go in and find specific things. So the segmentation is to find more of the big objects within the space. The object identification now is if I want to find individual valves, labels, objects within my reality data, I can now actually start finding these in a three-dimensional sense. I'll show you how this is going to connect together within preview and our future vision of how we see this fitting. Is it's finding it, but it's making it now available to do more, connecting data to it, cutting and removing it from the space, which is what we've got some tool sets for that, and just allowing you to work with this data a little bit easier. From the editing side, this has actually been one of our kind of flagship tools we have over the years. And once we create this 3D data set, we can now actually start creating this interactive environment. So it's a cut tool data set we've had that allows for hole filling within the data. It allows you to start creating and cutting reality objects right out of your data set. This is where we get into some of our customers we've got now for doing virtual staging, facility planning, maybe it's scaffold planning on a project site. We can actually start creating the SimCity of an environment, but all from scan data you're capturing. So really just looking at how we can make this data more available. So having this available to export as a 3D data set as well, we can create subsets of the reality mesh. Export as OBJ, GLB files. We've got a new partnership with NVIDIA through the Omniverse platform. We export directly to USDZ now. So really trying to bridge this gap with making this data more visually appealing earlier in the process. One of the big features as well, we see things as now how we can extend more value in this data is now we can actually virtually stage within Preview 3D as well. The fact that we can actually import 3D data sets, so we import OBJ files, FBX, step files, IFC data, really any 3D file format, we can actually bring that into the space. If it's correlated already, kind of in a design file, you can bring it in with the actual coordinates for the project. Or if it's just objects you have, we've got an integration with Sketchfab where you can actually bring in any 3D content. So maybe it's some chairs or tables, or in this case, a CNC machine. We can actually bring it in, and it'll clash with the environment. You can place it within the space. So this is where we start doing more than just our mesh engine and what we offer at Preview. We're looking at this full end-to-end solution of how we can start leveraging this data even easier. And of course, the big one, we see kind of making this data, I wouldn't say a commodity, but making it more available to a wider audience. So the benefit of what we offer is we do have both a desktop and a web application that are meant for sharing out and with, I guess, use with as many people as possible. We can navigate with different avatars, first-person view, third-person view within your space. This is part of that intelligence that we're looking beyond the point cloud, getting to automatic clashing, and really kind of getting to even low hardware requirements. I know a lot of you probably run some pretty high-end design software. We've got incredibly low requirements even for running on desktop, where I'll open up our 1.3 terabyte data set and it's consumed about 5 gigs of RAM as a reality mesh. There was a comment yesterday about not being able to consume these data sets in a lot of software. That's what we're trying to do with our product, is actually make it available for everyone to use. Furthering of this is now how we can start collaborating in real time. Of course, we see this. This is a new feature we just launched here a couple of months, or actually, I think 2 months ago. It's actually how we're able to now start bringing different people and engaging within the space. But this is all just done within a web browser. So the fact that even in the virtual staging piece, we can actually publish these layouts that we create to the web. We can now actually start sharing these and communicating with others. You can see the avatars. We've actually got an integration with Ready Player Me, which you can actually create all your own custom avatars to, really kind of personalize the experience of bringing people into this reality ecosystem. So this is a really exciting one now. We can actually start communicating around objects in the space, talking about what we need to do. And this is all without ever touching a design software or doing anything other than scanning and converting to our product. One of the other exciting ones here too is a new IoT integration that we've done kind of an early POC on. We're going to actually be going to more production with this in the coming months here, is now how we can start connecting more information to this space. So the whole Internet of Things thing, being able to bring in robotic applications. The example you see on the right was actually a custom project we did for a company actually in Korea, where they actually wanted to bring in their robots within the space. They're all controlled by an API. We can actually start bringing that in and seeing it all within our reality data space. This ends up being 100% three-dimensional, very interactive, so you can actually start seeing where all of this goes on within your data set. On the left-hand side now is really the future of where we're heading to, is this connected asset piece. So honestly, all the work that Exxon and others have been doing this morning too, of bringing in this data, finding these objects and connecting up with information, just allows us now to do more, and we're trying to make that really easy to use and consume within our product. So before I jump into a demo, this is kind of where we get into the opportunities here. I think that's what kind of made me take the jump to kind of join Preview here a while ago, is we want to do more with this data. We can all scan and create this beautiful point cloud, but if we can't actually start solving problems with it, then we're really not solving anything out of it. We're just kind of compounding the issue. So really from our side, we're looking at virtual tours, collaborations. We can use it for design. We can use it for relocating equipment is a big note we actually have for some use case with the customers. We can scan 2 facilities and cut equipment out and move them between spaces without ever touching a CAD application. Asset management is a new one we're really excited about with our segmentation tools and the ability to cut objects and attach data. This is really where we're focusing a lot now, is how we can take this data, make it more usable to more people. So again, I did have a video, but I do have a live version that I'll show you here too. So I like live demos to show how well these data sets open and what we're able to do here. And I do have an avatar of Matt, so if anybody really is ever excited about being Matt Bird for a day, you get the opportunity to do that here today. I'm just going to load a different space here. So what I'm doing here, this is actually a like RTC data set, so just a regular run-of-the-mill terrestrial scan data set, other than it's captured with a lot of overlap and it generates the data set in real time. So we've taken this data set and it's all created as a reality mesh. So the way you can actually jump into it is we dive into this very interactive 3D data set where you can actually start fully navigating around in 3 dimensions. You start seeing how we can see the quality of the mesh in the background. We can actually see the level of detail we're still able to preserve from the data. So we're trying to keep as much information as possible to keep that level of accuracy you've got with the initial data you're capturing. And of course, not every data is created the same, but as we get into looking at terrestrial scan data, gives us the nicest, cleanest data set within a data set. But now if we look at how we're able to kind of dive, and you can even see like the valve stem on the wheel. So this is really what we're trying to get after, is preserving as much information of the data set and seeing as much detail as possible. But with the photo texture we get from the imagery, is now we can actually start seeing the space a little bit differently than you can with a point cloud. Shapes start coming together. We've got occlusion baked in, so you can actually not start seeing through. You don't see through walls. You don't see through equipment. And this is where we now get into this more of an immersive video game environment. We actually have Clash baked into the space. So as I start walking through the environment, I can now actually start hitting objects because I actually know a bit more about the space because it's as a connected mesh. So, I don't know, we didn't have a lot of pictures of Matt without a hat on, so he had to kind of fake a picture. So I told him by the end of the conference, I need to get a picture of him without a hat so we can build a better version of an avatar of him. But with this, it allows us to actually fully immerse yourself in this space. But now we get into some of the feature sets of really what we want to offer, is now the ability to start cutting and slicing and dicing data within the environment. This allows us to hopefully only model as needed within a design environment. So right now what I'm doing is actually performing a cut on this space, creating an editable object. Now I actually have this piece of equipment that I can now actually have as a editable asset within my space. The goal of what we're trying to do from here is now the segmentation stuff I showed you in the slide is automatically, as soon as you process a data set, it will already know where that pump is or that piece of equipment is, and it'll already be segmented. Then you can choose what you do with it. I want to cut it and remove it. Maybe I want to do some virtual staging and bring a new piece of equipment in here. So I can actually go to my library, bring in a 3D data set, put it in its place. So this is where we start getting into this. I like to say the SimCity for reality data is having a different way to work with this that's 100% visual. Benefit of this is it still keeps all of the clash baked in. So I can now actually start planning a new space, seeing if it's going to fit. If I have a piece of equipment I need to bring in, how do I get it there? How do I bring it into my project? So this is really where we're trying to just, again, make this data a little bit more fun. So this is one of the neat data sets just because it really does show the detail of the meshing of what's possible. But I'll dive into just one other data set here, and then we'll maybe jump to some questions. Actually, the castle one I'm going to do. Just even show what's possible with even a Navis data set here as well. The level of fidelity is going to be a little bit lower, but actually the quality of what they're doing with the sensors is actually pretty stunning. So we're able to kind of bring ourselves into this immersive space. And with this, looking at some more historical type data, this now just allows you to start experiencing data a little bit differently. So I can now actually walk, I can run within my space. It's got stairs here, you can actually crawl, like walk around. So it really makes everything very interactive within your data set. But we really like the Navis data set because it does give us a lot of overlap, a lot of really quality images that go along with it, and the speed of capturing is just phenomenal. So that time to end use is really what we're trying to make as fast and easy to use as possible. I could show you data as much as we want. I got a bunch of tools in here for doing floor plans and creating ortho photos and really trying to engage and bring data into it, kind of back into the ecosystem, but hopefully it kind of gives the idea of what we're trying to do and why we're trying to be a little bit different with the product that we're offering. Perfect. So I think I got another slide to jump back to as far as the end slide, but that's, yeah, I'd love to open up for questions, I guess, here, and we're around. And maybe before we do stop here, we are sponsoring the Happy Hour event here as well, too. We're really excited to be part of RCN and kind of open up the community and let people know what a small little company like us is doing up in Canada. We've kind of made a big name for us the last couple of months here, and we're getting to be known a little bit more. So hopefully you guys are excited about what we're doing and where we're heading. So leave that.